Welcome back to Intro to Physical Anthropology. I'm your instructor, David Leitner. Today, we're going to finally meet some of these early hominins, these early bipeds who led to all of this, you and me. There's going to be a lot of facts out there. I think they're interesting facts, but I also understand that it may not be everybody's cup of tea. But there are some really important things to remember throughout this. Mainly that although we've got three very good candidates for the first bipeds, there isn't really any way at the moment of telling which, if any of these, is the actual ancestor of us. The best we can probably do is say one of these may be more like what our actual ancestor was than the others. In other words, one of them might have a more recent common ancestor with us than the others. That's more likely than any of them being the exact ancestral line. So, with that in mind, let's get started. All right, so terminology first. You're going to hear me using a term that may sound unfamiliar to you. The word is hominin. I use this generally instead of hominid, which some of you may or may not have heard before. It has been the scientific name for fossil humans and ourselves in the past, but really over the past couple of decades, the way we name things has changed considerably, and we're using less of the sort of strict Linnaean sort of categories of levels of organization, and going to more of that phylogenetic model that we talked about in previous chapters. That has resulted in some renaming of groups. Sometimes that can be extremely confusing. So in the old sort of strict level-based, classification, the family was called Hominidae. It's still Hominidae today, but who's in it has changed. At the family level, we have a split nowadays between Hylobatidae, which are the gibbons and the siamungs, and the Hominidae, which are the great apes. So Hylobatidae are the lesser apes, orangs, gorillas, chimps, fossil humans, and humans. We're the great apes. Okay. So hominid used to be an appropriate term for a member of the family Hominidae. It still is, only now it doesn't mean humans and fossil humans exclusively. Nowadays, when you mention hominid, what you're really saying is all of the great apes. Instead, now we have these other sort of more phylogenetic categories that represent the actual evolutionary history a little bit better. Of course, there was a big split between orangutans and the rest of the apes about 14 million years ago, give or take, especially as Asia, the forests of Asia and Africa become more and more separated. And so now you've got the Asian apes and the African apes. African apes being Homininae. Finally, you have the tribes. The tribe of Hominini is fossil humans and humans. So we call these hominins. I'm going to generally use the word hominin. I may slip up every once in a while because when I was learning this stuff the first time, it was hominid, so I'm still readjusting just like everybody else is. But it's good to be aware of this. Most of the time nowadays when you see hominid, if it's an older paper, it probably means humans and fossil humans. You need to sort of double check, though, that that's what they mean from context. Okay. Searching for human ancestors is basically a search for a mix of traits. And what I mean by that is the first hominins are going to be very closely related to the most recent common ancestor with chimpanzees. Humans are human-like. Chimps are chimp-like. And our most recent common ancestor with chimps was kind of both, right? It wouldn't have been exactly like either of us, but would share a bunch of traits. Well, the same is true as we look at the early branch of the hominin line here. When we're looking for ancient hominins, we are looking for a mix of ape traits and human traits in different degrees. Okay? In other words, the older it is, the more we expect to find ape traits, and the more recent it is, the more we expect to find human traits. Now, some of these traits, so that we know them when we see them, include just in the mouth itself. Remember I said jaws and teeth are highly, highly selected because they are how we process food, and that has a big impact on reproductive success. Also, they have a great deal to do with mating in terms of the apes because of displays with large canines and so forth. So they play an important role in evolution. So we can look to them for differences between humans and apes to identify in early hominins. Modern humans have a wide parabolic dental arcade like this one on the bottom here. You notice the sides are not parallel, unlike the ape sides, which are sort of more U-shaped and parallel. The modern human has smaller anterior teeth, both incisors and canines, and also smaller posterior teeth, which includes the premolars and the molars. There is thickened enamel compared to apes, and we are missing something called the CP3 complex. This is the CP3 complex. It stands for canine premolar 3 complex. So it's a mechanism involving the canines and the third premolar on the mandible, which allows the upper canine to be honed, sharpened on a regular basis every time the male opens and closes its mouth. This is very prevalent in all apes, except for us. It's very weird. We don't have this. And part of what we're going to need to look for is, when does this disappear? Because it may have implications for how we arranged our mating as well. Large canines, a lot of male-male competition for mates, so probably a great deal of sexual dimorphism, right? But smaller or missing large canines, well, less sexual dimorphism may mean less competition between males, more likely monogamy or some other kind of lower conflict mating arrangement. Okay, in the skull in general, there are several things we look for. The main is a general agnathic appearance in humans. Apes tend to be more prognathic. What do I mean by this? Prognathic means the jaw is sort of jutting outwards. Agnathic means it's more inwards. So in other words, we have much flatter faces than other apes. And as you can see from the examples here, those angles change significantly over time, right? Here is Pantroglodytes, the common chimp, with a very prognathic angle here. And as we get closer, here's Homo habilis, much less so, Homo erectus, less so, and on up to ourselves. We have very, very agnathic faces. This may be one of the reasons our teeth are so small, so they can actually fit in the jaw that is continually getting shorter. In general, too, we notice an increase in size of brain cases. As I'll point out later, we don't really see that significantly change until much later on, but it's something we want to keep in mind as we move forward. Okay, so who are these late Miocene bipedal apes? I'm calling them bipedal apes because that's what they are. They're very, very early. Yes, they are. We could call them human. We could call them human by dint of the fact of their being on the hominin, in the hominin tribe. But in terms of their actual behavior, they seem more like late Miocene bipedal apes. Okay, there are three main candidates, and they span about 4 to 8 million years ago. One big problem about studying this time period is that the actual fossil record is sparse. Not a lot of things fossilized. Maybe not a lot of good environments. We know that there were a lot of heavy forests. Heavy forested environments tend to not be kind to fossils. We tend to find them more around watering holes and volcanic plains, that sort of thing. Could also be we're just looking in the wrong place. We're just assuming that the origin of bipedalism is in one of these areas, and it could be in a completely different area that we're not looking at. So, as I said before, we don't know if any of these three, Sahelanthropus chadensis, Ardipithecus ramidus, or Orrorin tugenensis, it's taken me years to say that effortlessly. Try to say it 5 times fast. That's your homework. We don't know if any of them are direct ancestors of ours, but we can surmise certain things about that ancestor based on these finds. Okay, we'll start with one of the oldest, Sahelanthropus chadensis. Nicknamed Tumai, which in the local dialect in Chad is hope for life. It was found initially by Michel Brunet. It dates from 5.2 to 7 million years ago. Now, here was the first really important thing about it. Found in a dry, lightly forested area near a lake shore. Okay? Second interesting thing about it is it's got a foramen magnum near the base of the skull. It's positioned like a biped. Problem is, although we have a fairly complete skull and mandibular fragments and some teeth, we have no postcranial remains whatsoever to talk about whether it was actually bipedal or not. It fills in a key evolutionary gap regardless because we have so little data about apes during this time period. So it's important no matter what. And it's important because it might push human origins far to the west of the Great Rift Valley, which is where most of the focus on human origins has been. What's human like? It is less prognathic than we would expect. We would expect something that recently evolved from apes to have a much more prognathic profile, but it does not. It has a large brow ridge, which is a larger than expected brow ridge, which is a lot like later hominins. But the canines are very small, and it has already got a non-functioning CP3 complex. That is, the CP3 complex no longer functions to hone the upper canine. And there is no diastema between the bottom canine and the third premolar, which allows for that complex. So not only has the complex disappeared, it's closed up. And most importantly, anterior placement of the foramen magnum indicates probable bipedalism. What's ape like? Very small brain, chimp size, 320 to 380 cc's. U-shaped dental arcade. So, yeah, the teeth themselves are missing a bunch of ape traits, but the shape of the jaw in general is very ape-like. The enamel is kind of intermediate between chimps and Australopiths. Well, that would make sense if this is an intermediate form here. It has had some major taxonomic controversies. Some people claim it is actually an ape species, not a hominin species, that the shape of the skull is the result of crushing. In fact, it's very fragmentary, as you can see. It took a lot to piece it back together. And in fact, actually, a lot of scientists criticize it for that there's just too much interpretation. Maybe even the placement of the foramen magnum may be more about the way, the hopes of the researchers than the actual fossil record. Others suggest it be lumped in the genus Ardipithecus, not in its own genus, even though it's discovered several thousand miles away from the nearest Ardipithecus remains. All right, second candidate here, Orrorin tugenensis. You know what? I just realized I am gendering these as men, and we don't have enough to say whether they were male or female, to be honest. So they. Orrorin is sometimes referred to as Millennium Man, right after I talk about gender, by Martin Pickford and Bridget Sennett, discovered in 2000. That's why it's Millennium Man. Found in the Tugen Hills in Kenya, which is where it gets its species name, tugenensis. It just means from the Tugen Hills. It is approximately 6 million years old. That's great. That's right around where the genetic dating of the most recent common ancestor would be. Fossils, fragments of the cranium, and several fragmentary postcranial remains, and multiple femur fragments. Whether or not it should be a new genus is disputed. Again, same thing. Maybe this is Ardipithecus, maybe it's an ape that we're just reading too much into. Why do they think it's bipedal? Because the postcranial features look like a biped. It seems to have a larger body size than we expected for this time period. The internal femur anatomy looks more like a biped. It has thick enamel, but it has an ape-like upper canine. So the biggest thing is the proposed angle and length of the femur. But even that has been argued to some degree, that there may be too much interpretation going on here. So again, big question mark, promising, but big question mark. Are they justified in giving it a new genus name? I don't know. Could be. Ardipithecus is our third candidate here. Ardipithecus is great because we've got much more complete fossils for Ardipithecus than we do for either of the others. Ardipithecus' name means ground-dwelling root hominin. Not meaning that it eats roots, but that it may be at the root of our family tree. We have two species based on two fossil finds. The first is ramidus, Ardipithecus ramidus, nicknamed Ardi. That was the first one discovered and is about 4.4 million years old, which makes it almost contemporary with the earliest Australopithecines, as we'll find out, which is exciting. And the other species is Kadaba, 5.8, 5.2 million years old. The team that found Ardi, both actually, consists of Tim White, Brahani Asfa, and Ken Sua. I'm probably butchered their names, and I apologize for that. They found them in the Middle Awash, in the ANTHR Triangle, which includes parts of Ethiopia, a little bit of Kenya, that sort of area. The most important thing is that this is the key find that told us the impetus for bipedalism has very little to do with grasslands. Because here we've got a biped with many of the major changes already in place, but living in a dense forest. So what does that mean for the emergence of bipedality? Well, let's look at the similarities and differences. It's a hominin in that it has thinner enamel than an Australopith, but also much thicker than an ape. Again, that's intermediary. That's a good sign. Post-canine megadontia. That is the teeth behind the canine are larger. Okay? This also sort of is something we see that happens in Australopiths as well. There is an anterior placement of the foramen magnum. So again, good sign of bipedality. This time it's less controversial because of the state that the skull was in. And the pelvis indicates bipedality, right? It's much more bowl-shaped. It has more of a turned ilium. So it's probably not walking on all fours. That said, it may be doing so sometimes. It's not a full biped yet. What's ape-like? The arms are long compared to the legs. It has an abducting big toe that it can grab. And it's heavily reliant on arboreal activity. Chimpanzee-sized brain, and ape-like molars. Okay? So, there you have it. We've got this really interesting sort of set of features here that makes it a definite biped, but it's still very ape-like, and it's a biped where we weren't expecting to find one. Most important things about it. It indicates that traits assumed to be associated with early hominins also arose independently in other lineages. Okay? And so, this may have been a knuckle walker much of the time, but also did some bipedalism, and has a higher degree of sexual dimorphism than we expect to find. Some even argue that Ardipithecus isn't a hominin at all, it's an ape. However, most scientists at this point accept the lineage as being closely related to our most recent common ancestor. So there you have it. 3 hominins that are very important in this part of hominin evolution. They mark the earliest phase. In this phase, the features of bipedal locomotion are being put into place, but it appears they're not being put into place because of grasslands or other things. They're being put into place while living in trees, probably for reaching further into the branches. So you stand up on one branch, brace yourself with one hand, and lean out to grab. We think that's probably it, because the feet still grasp. They're still, the hands and feet are still adapted for arboreal living. But they've already got many of these other features that are associated with bipedalism. So, again, points out that bipedalism is not a single trait, right? It's a combination of traits that produce or enable a particular behavior. Actually, now, for us, we're obligate bipeds. We can't actually walk well on all fours at all. We have to get on our knees to do it. But these guys could go back and forth. Okay. The earliest changes we notice are things like the shift in the foramen magnum, shift in the pelvic shape, and early loss of the CP3 complex, along with smaller teeth overall. That's important. It's also clear that by 4.2 million years ago, bipedal hominins had diversified into at least one major genus, and Australopithecus comes on its heels. Australopiths are what we're going to talk about next time. And just to foreshadow, they are an incredible group of hominins that, with a longevity and a diversity that is really unmatched in the rest of the hominins. like I said, the earliest Australopiths may have been contemporary with Ardipithecus, which is very exciting because that means there may have been more than one biped on the continent at the same time, on the Earth at the same time. But one of the things we're going to find out about Australopiths is after that initial situation, there be multiple biped species becomes the norm. Actually, it is the norm right up until about 27,000 years ago. That is when we became the only bipedal hominin, the only hominin, period, in existence. It's kind of we're going to look into that over the next few weeks. I hope you enjoyed this. We're going to move on to talk about Australopithecus in general in the next video, and then we're going to talk about gracile Australopiths in another video and robust Australopiths in a final video. Australopiths are really interesting. It's where the biped wagon really gets rolling, and we'll see a great diversity of behaviors as well. So, anyways, take care of yourself. Have a great week, and I will see you soon.